Personal finance practice problem using OneNote. Future value of an annuity using non-annuity Excel functions. Prepare to get financially fit by practicing personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side. We're in the Practice Problems tab down in the 1245 Future Value of Annuity using Non-Annuity Excel Functions tab. Also note, when using OneNote, take a look at the Immersive Reader tool. Our practice problems will also be in the text area with the same name, same number, but with transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got the information up top, calculation on down below. We're looking at the future value of an annuity. We want to be comparing and contrasting the calculation using an annuity formula and noting that we can break that calculation down into basically a series of non-annuity or simply future value non-annuity calculations as well, which is useful to know the relationship between annuity calculations and non-annuity calculations, and it can be useful for us to actually see the payments in practice on a year-by-year basis. It's also helpful to know that basically if you do have something like an uneven series of payments, then you can basically use this method to do that. So note that when you're in it like a school setting, or if you were to try to do calculations with the use of tables or the use of basically mathematical formulas, then that would incentivize you to try to fit all of your calculations into some kind of groups. Annuity calculations are going to be more and more helpful in that scenario so that you can limit the number of math calculations you're going to need to do as you run different calculations and whatnot. However, realize that in Excel, it's a lot easier for us to do that. We can set up a table and we could do present value or future value calculations on a year-by-year basis, and that could be quite useful if you're looking at more complex situations. So if you do have a situation where you're looking into the future and you're trying to say, okay, I'm trying to figure out a series of cash flows that are going to happen in the future, but they're not all even. They don't happen to all be the same amount over a series of periods, or there's some grouping where I think they're going to be similar for this amount of periods and then change on the second amount of periods or something like that, then it is quite possible using spreadsheet programs to work something like that out easily by simply using future value of one calculations instead of trying to cram it into an annuity due to the complexity of the math. So realize that if you're in a school setting, you may start to feel that you need to kind of adjust everything to be more simplified than possibly it needs to be if you use Excel sheets, which basically you can break things out on a year-by-year basis, which is also useful to do even if it is simply an annuity calculation. Okay, so what we have here is we got the payment of $1,000, we got the rate at the 7%, the periods are going to be 5 years. That means that if we were to just take that series of payments, it would be 5,000, 1,000 times 5, but if we were to take the future value of it, and we have the rate of basically return of the 7%, it would be more like the 5,751 valuing it at 5 years out into the future. The normal formula of an annuity then being equals negative future value. That negative sign is going to flip the sign, which would result in a negative result to a positive result. You can put that negative in front of the payment. I like to put it in front of the FV brackets. Rate is going to be the 7%, comma. Number of periods is going to be 5 periods, and then comma, and the payment is going to be that 1,000, and that gives us a nice 5,751, cleanly done, easily done here, one calculation. But we could break that down into a series of 5 payments, and then instead of doing annuity calculations, we do simply 5 future value of 1 calculations, and then we could just add up those 5 future value calculations. It's a little bit more complex if you saw us doing this on the present value side of things. It's a little bit more complex to set up the formula, because when we think about the years, we're not basically taking this year 1 back 1 period to year 0. We're taking this forward, right? This first payment that happens, we're thinking about, okay, this payment we assume happens at the end of the period, and we're trying to bring it forward 4 more periods, period 2, 3, 4, and 5. So that complicates the formula a little bit when we do the calculation, a little bit more than when we do the kind of the present value similarity between the annuity and present value of ones, but same kind of concept here. So the formula would look something like this. We're going to say, okay, I got these series of payments. Let's just look at all of them. There's the 5 payments. They add up to 5,000. This first one, we're going to take the future value of that 1,000, basically 4 periods into the future. So the way I would set this up is to have the table in a similar fashion as we saw with the present value, in that I would like to have the years listed out with individual numbers in it, so I can use those numbers in my calculation on the right instead of having to hard code or type in the number of periods on the right. That'll help me to copy it down, although we're going to need a little twist when we do that here. So we'll see that. So we got the negative future value. It's going to be the rate. The rate's going to be that 7%. It's picking up the 7% up top into this table. That's why it's an absolute reference indicated by the dollar signs before the B and the 4. You only need a mixed reference, but an absolute reference will work so that when we copy this cell down, that rate will not move down relative. Anytime you have something that's outside the table in your data set, then oftentimes you need an absolute reference to not have it move down. Comma, number of periods. Here's where the complication comes in, because it's not going to be 1. I'm not discounting this back 1 period like we are in a present value. I'm taking it forward to the remaining periods left, which is 1, 2, 3, 4 periods left. So the question is, well, how can I put that in here without just typing 4? Because then when I copy it down, I'll have to type a 5, have to type a 3, and then a 2 and a 1, and so on. How can I, do this with a formula that I can copy down? One way is I could say, well, I could take the 5 periods, the endpoint, minus the 1, the period that we are on, which would result in the 4 periods remaining. So I'm going to do that with basically a formula. This cell represents period 5 here. This cell represents the first period, this period 1. And then there's another little twist to it. I can't just leave that period 5, even though it's in the table we are working on, without an absolute reference, because when I copy it down, what I want to happen is for this to take 5 minus 2, meaning that 5, even though it's inside the table, I want it to stay the same, and I want this cell to move down so that when I subtract them out, I'll always get to the right number. So we're going to make that period 5, an absolute reference, minus the current period we are on, which is period 1, 5 minus 1 being 4, the remaining periods left for this future value. Then, comma, we don't have the present value because we don't have a payment because it's not an annuity. And then we do have the present value, which is the 1,000. If we take that future value of the first period out, 4 periods at 7%, we get that 1,311. Then if we copy this down, same thing, we copy the formula down, we get negative future value, the rate still 7%, same exact cell because we used an absolute reference, comma, here's the funny point, the number of periods is now 1, 2, 3, 3 periods left that we want that to be. We don't hard code 3, we copied it down, and we made this 5 an absolute reference, so this is the same cell, minus this cell changed from G2 to G3, changing the 1 to the 2, so 5 minus 2 is now 3, because there's 3 more periods that we're going to take the future reference of, comma, and then we don't have a payment because it's not an annuity in this case, and then comma, we got the future value, which would be the 1,000. If we take the 1,000 at the growth rate of the 7% for 3 periods, we get the 1,225, slightly less than, of course, period 1. Let's do it one more time, since this is more of a complex one than the present value. We got the negative future value, the rate. Rate is once again the same, representing the 7%, comma, number of periods. That 5 cell, the cell representing 5, is absolute, has not moved, dollar signs before them, minus G4, which has moved from G3, now representing that 3 here. 5 minus 3 is the 2 periods that are remaining. And then we've got the comma, and 2 commas because it's not a payment. The present value is that 1,000. So if we take that 1,000 forward 2 periods into the future at 7%, we're at the 1,145. If we continue this process, period 4, that 1,000, 1 period out because we have 1 more period remaining. Future value 7%, we get the 1,070. And the last one, no difference, no change happens because we're at the end that the payments happen at the end of the period. So that would give us that 5751, once again 5751, and you get to see then, the present value on a year or period by period, in this case year by year basis, which can give you some more information than simply doing the one calculation getting you right here. And like I say, if you have different cash flows in the future that you can't squeeze into an annuity, you don't have to go, oh my goodness, this is going to be just a mess, too difficult to do. I have to at least simplify it down to having all the same payments, or else I have to, do some long, tedious process. No, it's really easy. You just you just list out the years, you list out the payments, whatever they happen to be, if they're not even, and you just take it year by year, which gives you more information anyways. And then you might also see it this way, which is just inverting the table. This is often useful especially if you're trying to figure out what the future cash flows will be, and you're trying to, you predict what the cash flows will be, and you come up to, your inflows and outflows, and then you get your bottom line of what the cash flows are for years 1, 2, 3, 4, and 5, and then you could do your calculation basically down here, same kind of thing. The first one, future value of the rate, 7%. We've got it absolute reference, $ before the B and the 4, so that when I copy it to the right this time, that cell up top, cell 7%, the one with 7% in it, will not move to the right. It's going to stay the same. Number of periods is now going to be this cell, 5, which is an absolute reference, minus this cell, which is 1, which is not absolute reference, because when I move this cell to the right, I want the 1 to move to the right to the 2, but the 5 not to move, the result there being 4 in this one. And then comma, and 2 commas, because there's no payment, and the present value is the 1,000 discount, or not discounting it, bringing that into the future 4 periods gives us the 1311. And then this one is this one over here. We got the future value. We have the same rate because we absolute referenced it. That's the 7%, comma, number of periods. This cell 5 is the same because we made it absolute, minus M1, which is now representing 2, which moved from L1 to M1. So now we got 5 minus 2, which is representing the 3 periods after that are remaining, comma, no payment because it's a annuity. I mean, it's not an annuity, comma, the present value of the 1,000 then gets us to that 1225. If I did it again for period 3, 1,000, 2 periods forward at 7% gives us the 1145. And then this one, 1,000, 1 period forward would give us the 1070. And this one is going to be the same because it's at the end of the period. And that will then give us that 5751 again.